First question says the point 12, 5 lies on circle with center 0, 0. Write in the coordinates of another 3 points on the circle. So since the center is 0, 0, make a rough representation. This is our center over here, 0, 0. Now the equation for a circle is x squared plus y squared equals to r squared. Now r squared is our radius. So r squared is going to be 12 squared plus 5 squared, which is basically 169. So x squared plus y squared equals to 13 squared. Because 169 is 13 squared. So now if we look at this, 13 is the radius, which means for another set of coordinates, radius is the distance from the center to the circumference of the circle. So this is a distance of 13. This is a radius. This is a distance of 13. And the point we know is 12, 5. So 12, 5 is probably going to be somewhere over, let's say over here. This is 12, 5. So which means this can be a point on this circle as well. Just going to be 12 and negative 5. Or you can have a point over here, which can be negative 12 and positive 5. So we have like just several possibilities like this. So the set of coordinates I'm going to choose is negative 13, 0, 13, 0, and 12, negative 5. These are the 3 points in the circle. Next question says expand and simplify. So we have x minus 3 whole power cube. So we can do x minus 3 squared times x minus 3. So x minus 3 squared is basically x squared minus 6x plus 9 times x minus 3. So now we multiply all of the terms of the first bracket with all the terms of the second bracket. That's going to be x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Negative 6x times x is negative 6x squared. Negative 6x times negative 3 is positive 18x. 9 times x is 9x. And 9 times negative 3 is negative 27. So that equals to x cubed minus 9x squared plus 27x minus 27. What we did is that we collected the like terms. So negative 3x squared minus 6x squared is negative 9x squared. And 18x plus 9x is 27x. So this is your answer. Next question says that we have this sine graph, which has the equation of y equals to sine of x plus 30. Write down the coordinates of A and B. So the coordinates of A, I'm going to put y equals to 1. So that's going to be 1 equals to sine of x plus 30. Then we do sine inverse of 1 equals to x plus 30. Sine inverse of 1 is 90. So then we do x equals to 90 minus 30, which is 60. So A is 60 and 1. For the coordinates of B, I'm going to put y equals to 0 because B lies on the x-axis. 0 equals to sine of x plus 30. Now sine inverse of 0 is either 0 or 360. Obviously, B does not lie on the origin, so it's going to be 360. So 360 equals to x plus 30. And then we do 360 minus 30 equals to x. So that's 330. So B is 330 and 0. That is your answer. Next question says there are 20 sweets in a box. There are white lemon sweets and the rest of the sweets are orange. Florence takes out 2 sweets at random from the box. Find an expression in terms of y for the probability that Florence takes 2 lemon sweets. If there are y lemon sweets and there are 20 sweets in the box, so y over 20 is the probability of Florence taking 1 lemon sweet times, for the second lemon sweet, it's going to be y minus 1 over 90. The reason why it's y minus 1 over 90 is because she is taking 2 sweets. So when she's taken the first sweet, there's 1 less lemon sweet in the box. So since there's 1 less lemon sweet, that means the total number of sweets has also been reduced by 1. Hence, it's times y minus 1 over 90. So that's going to be y times y minus 1 divided by 20 times 90, which is 380. Last question says, shown is a frustum of the cone that had a perpendicular height of 40 centimeters. So the entire cone had a height of 40 centimeters, like the perpendicular height. And right now they have shown us, like for the remaining part, that's 20 centimeters. The diameter is shown as 18 centimeters. So that means the radius would be 9 centimeters, half of this. This is 9. We have to calculate the surface area of the frustum. So since the entire perpendicular height was given as 40 centimeters, let's find the curve length, because that's what we need to find the curved surface area of this frustum. So for the curve length, we will do 40 squared plus 9 squared equals to L squared. The reason why we're applying Pythagoras over here, because if we complete the cone, if we complete the cone like this is basically your 40 centimeter height. This is 40 centimeters. And this is 9. So to find the curved surface area of the entire cone, we apply Pythagoras because this is a right angle triangle over here. So 40 centimeters squared plus 9 squared, and that is going to give us 481. Take the square root of that, and that equals to 41 centimeters. So the entire curve length, this is L, which is 41 centimeters. So now as you can see, the entire perpendicular height was 40 centimeters. And the one that's given for the frustum, that's 20 centimeters, which means the cone was cut in the middle. So both the halves were like, the lengths were like equal. So since the perpendicular lengths are like, half of each other, that means the radius is also going to be half. So if for the base, the radius is 9, for this part, it's going to be half of 9, which is 4.5. So now that we know the radius of the top part, we know the curved surface, we know the curved length of the cone, what we're going to do is we're going to find the surface area of the entire frustum. So as you can see, we have a top and we have a bottom base. So there's a circle on the top and circle at the bottom, then we have this curved part. So A1 is going to be pi 4.5 squared. This is the top part. A2 is going to be the bottom part, which is pi times 9 squared. A3 is going to be the difference of the entire cone and the cone that has been removed from this cone. So by that, what I mean is that the top part of the cone, which has been removed, we're going to subtract the curved surface area of that cone from the entire cone. So that's going to be pi times 9 times 41 minus pi times 4.5 times 20.5. Why 20.5? Like I said, the shape was cut into 2 equal parts, which means since the perpendicular height of the entire cone was 40 and that of the frustum is 20, that means the perpendicular height of the top part of the cone, that is also 20. So for 20, if we see the curve length, that's going to be 20 squared plus 4.5 squared. And if we take the square root of 420.25, that's 20.5. Hence, the curve length of this part over here, that's 20.5. So we subtract both of these areas to get the area of the frustum, the curved surface area. And that is going to equal to 869.44. Area 1 is going to be 63.62 centimeters square. And area of the bottom part is going to be 254.47 centimeters square. So now to find the total surface area of the frustum, that's going to be the sum of A1, A2, and A3. So 63.62 plus 254.47 plus 869.44, and that's going to give us 1187.53 centimeters squared. That is the curved surface area. So to sum it up, first what we do is we figure out what's going to be the radius of the top part and the bottom part. Then using the perpendicular heights, we're going to find the curve lengths for the entire cone and the cone that was cut out. Then after that, we're going to find the area separately for the bottom part, the top part, which are basically two circles. And we find the curved surface area of the entire cone and the cone that was cut off. And using that